Did you know that Google personalizes many searches by city, and Also Asked is the only tool to access live People Also Asked data at city level? Try for free at alsoasked.com.
I was going to say that SEO with Fat Joe is as peaceful as this, but then the birds are all having fights.
Tired of SEO guesswork? Quadra's AI agent goes deeper to uncover high-impact optimizations and completes hours of SEO in minutes. Get started now.
So let's talk a little bit about computers beeping and booping. And if I remember correctly, they asked me not to walk to that part of the stage, so I'll try to stay here for a while. So what we're going to talk about today is basically three things. We're going to talk about what is rendering, how we do it in Google search, and also why you should care. I mean, you all sitting here lets me think that you probably do care a little bit, but hands up, who here knows what rendering is? Okay. Who here could implement a renderer? Yeah, okay, that's what I thought. No, just kidding. We won't get into how a renderer works specifically, but we're going to get a little bit into how rendering works and what it is for those of you who haven't heard about it or don't know what it is. So, what is it? Well, the more or less broken down description of it is it turns hypertext into pixels, which is a very fancy way of saying the source code that someone wrote or like that was generated by WordPress or the likes gets turned into the pixels that you see when you open a website in your browser. There is a process in between, because what you do is you open a website, you see buttons, you see images, you see text, you see videos, you see whatever, but you don't necessarily see like the HTML, right? But the HTML itself isn't like a bunch of elements that you can move around, resize, and click on. It's just a bunch of text that asks the browser to do things, right? So what you're interacting with on the website is like the dish. You can eat the muffin if you want to, but someone has to use a recipe to make that. And when we program websites, when we make websites, then we are kind of like giving the browser the recipe to make it for you, to make the dish for you. So basically, turning the thing there on the left side into the thing there on the right-hand side is the process of rendering. Now, rendering means a lot of very different things to a lot of very different people. If you are asking a JavaScript developer or a web developer, rendering probably means for them, where is this kind of like transformation of data and the template, put it together into this HTML on the left-hand side, where is that happening? So JavaScript developers or web developers more broadly will probably talk about server-side rendering, client-side rendering, and anything in between. If they talk about that, they don't mean this blue arrow taking one thing to the other. They are talking purely about where does this HTML get made, right? There might be JavaScript involved in making that HTML or turning that into an existing thing that you turn into the browser's answer. Where does that happen? That is what they are concerned with. If you talk about a graphics guy or a browser developer, they actually care about the blue arrow in the middle, and they are saying like, okay, so wherever this rendering has happened on the server or in the client, we don't care. But at some point, the browser on your device has to actually turn it into pixels. Fun fact, at Google search, we don't really care about the pixels that much. We do care about something in between. So let's look a little bit more into what this blue arrow is. So if we were to zoom in, we would see something like this. The browser goes to a website, example.com, and downloads the HTML. There's probably some CSS involved as well. It downloads these files. They're just text files. Hypertext, because they are more than text. They're formatted text if you want to. Formatted not for a human reader, but for a computer reader. And then it takes these two files and it parses them. So it needs to understand what is in there. You do the same if you read HTML. You're like, okay, so this is HTML, this is the head, this is the body. Okay, so you kind of have like a mental model of where in the HTML you are if you look at it, right? You know there's an image somewhere, so I have to seek in the body, where's the image? That kind of stuff happens in the browser as well. And what the parser does is it creates a mental model as well. The mental model in the browser is called the DOM, the Document Object Model. It does the same thing as well for the CSS. We just don't care as much about the CSS, and you don't need to care as much about the CSS either. That's just for people. These superficial beings that want to look at nice colors and fonts, we don't care. We just want to have the structure, right? So in this case, this HTML on the left-hand side has been turned into this document object model, which is like a tree with individual elements for the individual bits and pieces that were in the HTML. So we have one box for the H1, we have 2 boxes for the paragraphs each, and a box for the image. Why do we have to do this? That is because the browser needs to actually do something with individual bits. So instead of just turning all of this into like a huge image with pixels, we might have to actually rearrange things because the window is being shrunk or the phone is turned from portrait to landscape. And to be able to do that, to reflow these things, to rearrange them on the screen and get you new pixels that reflect that, we have to have them independently. So this is the mental model of the browser. This is the DOM. Now the DOM and the CSS OM, which is the same thing for CSS, they go into the browser's process called layouting. And layouting basically sees like, okay, so this is the space I have available. These are the settings that the user has specified. Maybe you have custom fonts. Maybe you have specific high contrast settings, these kind of things. And then it kind of like arranges them onto the available screen space or window space. And then it creates something called the render tree. And the render tree is then basically like a bunch of draw this rectangle, then draw this text, then draw these pixels. These kind of things are then used by the browser to actually give you the thing that you see when you open a website. And then, you know, painting happens. You actually get the pixels in front of your eyes. The last step, the painting, in search, we don't care about. We don't need the actual pixels. We're more interested in the DOM. We need to know the individual elements and how they relate to each other. We might also look at the render tree or the layout tree, but we don't necessarily need the actual pixels. And all of this happens in your browser within milliseconds. So this is a diagram that you might have seen in your browser at some point. You have a little bit of gray stuff that happens on the network. Then you can see like the little blue blips. That's the parsing that I talked about. Then you see like a lot of yellow. Any guess what the yellow is? That's JavaScript. Okay, so the yellow happens, and then you see like this huge, massive purple block in the middle that takes nearly a second. That is layouting. So layouting is what actually is expensive for the browser to do because it kind of has like all these puzzle parts and needs to actually put them and lay them out onto the window. And then you see like the little green blips. That is painting, so that actually gives you the pixels. And then you see a little bit of JavaScript because why not? Everyone loves JavaScript, right? So that is how rendering roughly looks like in your browser. And why do I even talk about it from Google's perspective, from search perspective? Because it turns out that if you want to understand what is on a website, and as a search engine we kind of have to, you need to know what is going on there. And you need to actually run the JavaScript, because the JavaScript might change or create or remove things from the DOM. That's what JavaScript mostly does. It manipulates this mental model of the browser. It's like, imagine 3 dogs, now take one away, now add a cat, what do you have, right? That kind of thing is what JavaScript does, and we kind of have to pass this on and actually run the JavaScript to get all the content that you might have on your pages. And we have been doing this for a really long time, and we've been doing this with a recent version of Chrome starting in 2019. So for the last 6 years, whatever, more or less what you see in your Chrome browser is more or less what we see when we render. But how do we do this? I mean, we can't just like pay a lot of people to open websites and browsers and then kind of like, I don't know, take screenshots or copy the DOM or something, right? So we have to somehow automate that. And the way that we do that is by running a bunch of things in parallel, right? So you probably have heard of Googlebot, you know crawling is a thing, but that's really just the very first stage. And then it hands over the things that it crawled into what we call the indexing pipeline. The indexing pipeline or the indexing system is a bunch of small, very specialized programs that work together. A bunch of these happen at the same time. A few of these might happen multiple times, and they do all sorts of things. One thing, for instance, that it does is it checks if there's something there. So it checks, like, is this actually HTML? Is this a PDF? Is this a doc file? Is this an image file? Is this a video? Is this a 404? If it's a 404, then, you know, we can't do much else. so we can adjust or drop the process there. It will also look for things like links. It will do a bunch of different things at the same time. And, interesting, fonts. It does things like figure out if we can actually do something with the information that we have here. It might also feed that back to crawling. So the robots exclusion protocol, it looks for meta tags in the HTML, like robots no index and these kind of things. And it parses a bunch of other things. But today we are only focusing on one thing, and that is the web rendering service. That is the one component that actually is dealing with rendering. So if you look at it, like the parser, for instance, extracts content. So if we already see something here, we might already start doing more processes. This is not an exhaustive list of the things that happen in indexing. But for instance, duplication. If we see no content because all of it is JavaScript generated, then we can't exclude things at this point. We can't say oh yeah, this is a duplicate, because we don't know if it's a duplicate yet. So we actually might have to wait and then actually kind of come back to that later once the web rendering service is done. A question that I often get is how do I know if my website gets rendered? It's very simple. If it got indexed, it got rendered. Everything that is indexed is rendered. Everything that is not indexed is probably also rendered, then something chooses not to index it, great. But everything gets rendered. Why? Because the ones that need it, we have to render, and they are the expensive ones. The ones where we render it and there was no JavaScript involved, they don't cost us much. So it doesn't really make sense to deal with the overhead of logistics and code and predictions to actually not render everything. What does it do? Well, it takes the HTML that the crawler got. It takes a bunch of resources if the crawler hasn't gotten these resources. And resources, by resources, I primarily mean like the JavaScript files, the CSS files, images, this kind of stuff. Gets actually pulled, pushed into the WRS system, the web rendering service, and then the web rendering service creates us a DOM tree. You can think of that as an HTML document that contains everything that was added and removed or changed after JavaScript ran. But fundamentally, it does that. It creates rendered HTML, if you want to call it that. So let's zoom in a little more. Fantastic, the fonts. So indexing asks a service wrapper that basically then looks into the cache, gets in the resources if necessary into the cache if they haven't been cached beforehand, and then actually plugs them into WRS, the actual rendering system. And if you wonder where the testing tools like Live URL Inspection tool comes in, that is happening in Google Search Console, and it directly plugs into WRS. Because if it is a live test, we don't cache things, so it actually ignores the cache. So that's why there's only a link between WRS and GSC. But what you see in Live Inspection tool is actually more or less what you see in rendering, except for when the cache comes in and might give us a slightly different version of the resources. The renderer itself, the WRS box, has a bunch of work to do with orchestrating and instrumenting browsers. Then it has like a bunch of running Chrome instances without a head. And these headless Chrome instances are basically taking jobs. If they crash, the job goes to another instance. So it has to deal with all of that. That's what we mean with orchestration and instrumentation. And then whenever we detect that something is done rendering, we get the rendered HTML back, and then we pass that on to indexing. Cool. That's a lot of infrastructure. That is a lot more complicated than I make it sound here, but it works surprisingly well. But why do you care? Why am I here? I could ask myself as well. And I'm here because I keep hearing that, oh, you don't render every page. Oh, JavaScript pages take a lot longer to actually get into the index. Or blah, 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 blah. I hear all sorts of things, and I find that interesting because most of that is misconceptions or misreading the signs that you get, because it's not that easy to figure out. So this, you probably should be familiar with this. This is in our documentation. It explains the process roughly. So a page goes in on the top left. Basically, it's in the crawl queue. Eventually, it gets crawled by Googlebot. Googlebot passes the HTML that it found onto processing. That's the indexing system that I explained. And as part of that indexing system, it queues a page for rendering. A renderer actually picks it up, renders it, and then gives back the rendered HTML. And the rendered HTML is what will be processed in the end and then potentially indexed. What makes this a little tricky is that a lot of people are saying like, oh, but we use JavaScript and this page took like a week to get updated. Well, it might have been that we only crawled it a week later. So you made the change, JavaScript or not, But we decided it's not important for us to crawl that now. So we actually just waited a week or 2 or 3 or 4 or a month or 2 to actually crawl it again. And that is based on crawl budget rather than anything else. So rendering doesn't play a role here. Making a change without involving JavaScript would have taken just as long, but you don't care normally. You seem to only care when there's JavaScript involved because you kind of like to blame JavaScript, I think. But that's okay. That's fine. I like to blame JavaScript. JavaScript is a terrible language, but that's a different story. Find me afterwards if you want to hear more about that. Cool. So once it's in the crawl queue and actually got crawled, it will end up in the render queue. The problem with the render queue is you have no way of measuring how long it will be in the render queue. We can do that because we have instrumentation that tells us when something was scheduled for indexing and actually entered the indexing system and when it actually got picked up by the renderer, but we don't expose this information because it's not as useful. And what would happen if we were to expose this information is that you would get very confusing numbers because sometimes something fails in rendering, we pick it up again. And sometimes we render something, it fails, we find out, oh, actually, we don't think there's that much content changing, or there was not much content changing last time, so we can proceed with indexing it without re-rendering, and we will eventually re-render and then update the index. So it is a very complicated process, and it would only give you very confusing numbers. But I can tell you that the render queue time is not your biggest enemy. Like, it's really, really quick, and it's not that much of a problem. How long does rendering take? Well, how long does it take to open your website? How long does loading generally take? If your website loads for a minute, then it's going to take a minute. If it loads for 10 seconds, then it's going to take us 10 seconds. It's not magical. It doesn't take hours for Chrome to actually render a page. It goes pretty quickly because it's a browser. You don't click on a website in your browser and then just go have a tea and come back like an hour later. Maybe if you live in Germany where you have terribly slow internet, but I don't think that's that much of a problem here. So you can't measure that time. You can't measure how long it takes to render inside WRS because we're not exposing these numbers externally. And then last but not least, some people are like, oh, but we did use JavaScript and you did not update the document and we could not like figure out how or why, so it must have been JavaScript. Sometimes it's just that we get the content very quickly, we look at it and we're like, oh, that's shit. And then we don't index it, or we don't update the index. Or we remove it from the index, and then they're like, oh, JavaScript is to blame. No, this is a content problem. So, I mean, you can't really measure that either. It's like, it might be that you make a change on a website without JavaScript, and it doesn't get updated in the index as well, or it might fall out of the index as well, without JavaScript being the culprit, right? So just because there's JavaScript involved does not mean that it always will get indexed or will never get indexed. It's just a matter of where does the content come from. And if you look closely, realizing that everything goes through the render queue and the rendered HTML is what we're going to look at this point, we don't know which content has been added to JavaScript, nor do we care. Content on a page is content on a page. We don't care if it comes from JavaScript or it doesn't come from JavaScript. So there are a few challenges here that make this trickier for you, and I understand that. And number one is measuring crawl budget is tricky. It's not easy to predict when something will get crawled again. So if you make a change, it might take a while for us to actually pick up that change, no matter if there's JavaScript involved or not, just because crawl budget is an issue. Crawl budget usually is an issue starting at like 10 million pages, so you shouldn't worry about too much about crawl budget, but if you have a smaller website, there's still crawl demand as part of crawl budget, where we might be like, well, this website hasn't changed in a year, why would we like recrawl it every day? We can recrawl it every couple of weeks. The other thing is you can't reliably measure render queue time. People have tried to do that, but because there's caching involved and there's batch requesting involved, if you timestamp things on your server and be like, I'm going to be clever and benchmark when it fetches resources, fetching resources and rendering are decoupled processes. As you remember, there's the renderer and then there's the caching layer. These are two separate things. And they go through the crawl queue and all that kind of stuff. So it might actually take longer. We might have actually rendered with an older version of your JavaScript than what you see in your server logs. So you can't really reliably measure how long something has been on the render queue. And the other thing is that we changed the way that date and time functions work inside the web rendering service. Einstein would be very scared of the way that our physics in terms of time works in the web rendering service. So you can't even use that to get an idea of when we rendered something. And again, just because something was crawled and was rendered does not mean that it gets indexed. So if you see something like, oh, it's not indexed yet, so it must be JavaScript, it must be hanging at rendering. No, it might actually be hanging at something else. It might be hanging at the parser level. It might be hanging at behind a more important page update. It might be hanging because we're actually not hanging. It's just like we're not interested in it and we're actually not going to update the index with it. So that's a tricky one. I think an important takeaway is the rendered HTML is what you need to look at. Do not look at the source HTML. Do not look at anything else. The rendered HTML, you can find that in Google Search Console. The rendered HTML is what you should look at. The median render queue time is 5 seconds. At median, 5 seconds in the render queue time, nothing to worry about. And we aggressively cache resources, so measuring things based on server hits is not as easy either. If you want to learn more, definitely check out the URL inspection tool. Lots of useful information there. And with that, I'd like to say thank you so much.
Demand sphere. Limitless visual insights from the SERPs. Unlimited dashboards and users. Easy to use and easy to scale your growth to new levels.
Monthly reporting making you want to shove sharp things up your nose? Try Dragon Metrics, the all-in-one SEO software with mind-blowing reporting tools.